With me as well is Noah Hetrick. Noah's another GIS guy at our Pittsburgh office. We did, our Cincinnati office actually developed this application that we've been speaking about. Noah and I were involved in the project, me on more of a project management level, but Noah was actually out in the field with the application that we're going to talk to you about. It's one of those projects where pretty much anyone who could walk in CEC was out in the field with one of these tablets. This was an all hands on deck mission. But Phil, thanks for the introduction. Yeah, there's some nice regulatory tones, I think, in this presentation. We'll talk a little bit about the background and the setting of the project, the need for the project, give you an overview of the technology. Just to caveat that a bit, you can fire some questions at Noah and I. We didn't actually do the development of the application itself. That was done in FileMaker. But we can certainly answer any questions that we can. We'll show you a bit of the tablet application, talk about the reporting and the GIS integration components, and then some of the challenges too that we faced, and some summary and next steps. So we're talking about ASTs, which are above ground storage tanks, which are obviously very prevalent in the industry, oil and gas industry, but also other industries that have these tanks. So they're above ground structures. They hold different types of fuel, it could be frac water, different types of fluids. And they are regulated in various ways across the country. You guys may have remembered the Freedom Industries spill, where there was a storage tank leak into, I think it was the Elk River in West Virginia. Hit some groundwater wells and hit the news as well. And there was a lot of coverage about that. There was some, they had to truck in bottles of drinking water. And because of that, the legislator reacted very quickly, and I think it goes along with John's presentation this morning, maybe somewhat irrationally, that they panicked and said, all right, well, we got to get every tank that's located in West Virginia inspected, and we want to do it by the end of the year. And so for a company like Cabot, where they have thousands of, well, over 1,000 tanks in West Virginia of varying states of quality, it required some very quick action. So they required conducting AST inspections, and then to receive what's called a Fit for Service certification through the state DEP, and then creation of these spill prevention plans as well. So obviously this was all within a very short amount of time, required some pretty intense inspection and field time, and a lot of logistical coordination too on the ground. There's just a quick map of the wells that the tanks that we're looking at. The major counties that we're working in was Wyoming, McDowell, and Raleigh in West Virginia. So I mentioned this before, we had a very extremely tight schedule for field deployment, data collection, and reporting. This is a quick snippet from the policy as it came out. So the statute was effective June 6th, which said by the end of the year, everybody's got to get their certifications and their tanks inspected. Even though June 6th, I mean, it says here it's a steadfast date, there was still some questions on, what exactly was required to be submitted. This was going on into the summer, so it really wasn't nailed down, I'd say, until even mid or late summer, what we actually had to do. Obviously, this is a lot of work, a lot of inspections, there's a lot of tanks. So we needed some sort of a tool that was going to help us internally, obviously benefit Cabot, but for us, I mean, we wanted to get this done as quickly as we could, just so we could do the reporting, minimize the amount of time the field staff had to spend on every tank. We also had to do site-specific health and safety plans. That was more of an internal requirement too. I think Cabot has similar requirements, but anytime our field staff goes out on a field on a job, we need health and safety plans. And specific to that is distance between to the nearest hospital, emergency facility, police, etc. That's just for us, our requirements, but multiply that by 600 or 700 or even 1,000 well sites, that's a lot of safety plans. So that was another component of it as well for us to do our job properly. In the end, we're looking at all the inspection data that was collected through the application, photographs. The law did require at least one photograph of every tank. There's a pretty heavy GIS component to that for location maps and also health and safety maps, which Noah will talk about in a little bit, and then some tank pad schematic plans. I threw the screen up here too. So as it turns out, they changed, the next year they actually changed the reporting requirements for these ASTs. I mean, pretty much when this policy came out in 2004, everyone was up in arms. You had some operators which just said, you know what, we don't even think this is going to last very long. We're not even going to inspect any of our tanks, and hopefully we'll cross our fingers. And it turns out the scope was reduced, but you know, Cabot was being proactive in saying, well, you know, we actually have all these assets, and it would be a really good idea to formally document them. But you can see in 2005, the scope of the AST inspection statute was reduced significantly. I think in the end, you only had to provide this information for tanks that were in areas of special concern. So this law has, they kind of took it back a little bit as we went, but when we were doing this work, we had all these requirements in 2004. So the technology we chose was a tablet application using iPads, so the iOS framework, but using FileMaker as the database solution. FileMaker is a really nice tool, pretty lightweight tool for creating quick forms and then syncing that to a database. You know, really we were on a pretty tight schedule here, so we had to do some really rapid form development, had to mimic some existing forms and checklists that were already given to us through work we had done before, but also as specified by the state. We really didn't need high-resolution GPS accuracy. Well, we knew generally where these tanks were. Cabot had a very good list that they had compiled. We're really just navigating to these tanks. We had Cabot field staff with us to help us find where these things were. So once we got to the site, we weren't taking, you know, sub-meter accuracy, you know, valve readings, measuring the containment area or anything. So that helped us as well because, you know, relying on just the iPhone GPS receiver is not as accurate. I'll talk about some considerations that we found out after. Also integration into SQL, SDE. We had a big GIS component, so FileMaker can work with those database structures, which I'll show you in a second. You know, we want something simple, just like our last presentation from GeoCortex, you know, something that folks are familiar with. They have an iPad, you know, it's very easy to see, they're familiar with the technology. It was very quick for us to deploy and train our field staff how to use it. And then one of the nice things about FileMaker is it's built-in data syncing tools and transfer tools. We're able to do that nightly syncing routine in the field. There are some challenges with that too, which we'll talk about. A real quick overview of the technology here. So we've got multiple users using iPads in the field, multiple field crews. They're collecting data and photos. Those are really the two main data streams that we're looking at. And that would sync up nightly to our FileMaker server. And the syncing could be done over Wi-Fi or cellular connection. You know, with the system, you can also built-in dashboard if you want to do actually look at like real-time data progress. If you want to look at different data analytics. For this project, we were on such a quick deployment. We didn't develop a dashboard to go with this. We were basically deploying crews and then getting the data back. But obviously, it's a necessary tool for many of the projects, and I'll talk about this. Another app that we developed for bat habitat assessment. We have more of a management tool that we're working on. So then once it's in the FileMaker server, I mean, the key thing is photos. The photos are actually synced directly to a project folder where the folks actually doing the reporting can actually look at those. They're organized by task, by date, by tank. I think for what we do, CC does a lot of environmental permitting, a lot of ecological work, environmental work. We have guys taking hundreds and hundreds of photos daily. The photo management aspect of this is really nice, and it's all really done within FileMaker. It's still one of the biggest challenges is, you know, it's not as much getting the photos to where you want them, but it's, you know, our field staff take hours to like sift through the generic titles on photos. Here it's labeling the photos according to however they're labeled in the field, adding captions, etc. It's a really nice workflow. And then the reporting too is an important part, which is also being done on the FileMaker side. We can get PDF and Excel reports very quickly. We're linking our FileMaker with SQL and SDE so that we could do some scripting and analysis, actually get our data-driven pages and our different types of mapping tools so we can actually do that automatically to get our reports out on time. So that was kind of a quick whirlwind tour. Noah's going to come up and talk to you about just a couple screens about what the application looks like.
All right, so as Mark mentioned, I was fortunate enough to escape the office and get to do some field work. And so I was down there, the first week we were down there, working on this in late September. And some days were better than others in terms of this application working, but in the end it worked well. So as Mark mentioned, there was no GPS component with this as far as site location. The first task once we arrived at each site was to select which site we were at. So we didn't use a QR code or anything. There was just a list that we would scroll through as an alphabetical order. We could filter and sort the fields, so that made it easier. But we were fortunate enough also to have the Cabot well tenders on board, and they were very helpful in identifying what the sites were and their strange names that they picked for these sites. So once we selected the site, we were moving on to the inspection. So as you can see, this is the secondary containment, which is typically down there. It would be an earthen berm, and there were specific volume calculations that were necessary to either pass or, well, hopefully pass or fail the inspection. And like I said, most of them were earthen, and they ranged from 30 feet long by 30 feet down to I guess the minimum length and width to arrive at the proper volume of containment. So, like I said, these calculations were done on the fly within the application, so there wasn't any time wasted for us calculating volumes and stuff. It was all done in the app as we entered the data, so that made it much easier for post-inspection processing of the forms. And this is a screenshot of the photo collection stage of the inspection. So we were required to take at least one photo of each site. We ended up taking 2 photos for each site, one showing the detail of the tank and one showing overall site layout. So one of the challenges in this was the naming conventions for each photo. As Mark said, we saved a lot of time by automating the process of naming a photo instead of having to sift through all the photos collected and associate them with each site. We did have a specific naming convention though that would automatically associate each site with the photos. So once that was achieved, the application would analyze all the data we collected and basically keep track of what parts of the inspection we completed. And at the end, once we had the entire inspection completed, we could log, basically, once you hit that home button, it would log all that information on the device for later upload to the server. So I'm going to hand it back to Mark.
You can see there's a lot of nice tools that were built in here. This is nice too, just to make sure that these field guys, before they leave, they got to make sure they see all greens. If there's a red, right, they need to go back and do it again. So,
and that would be a waste of time. So
yep,
we made sure everything was taken care of.
Right. So on the reporting side, like I said, photo management was one of the biggest challenges. We had these photo sheets were created automatically from the FileMaker server. Like I said, they're synced to our project folder, which we're sitting in Pittsburgh, but also placed them on these photo sheets. They're organized. The captions were added, the headings were added based on all the data that was collected. The neat thing too on the app, you can take several photos, and there's a little checkbox in there that said you can include on the report or not. So if you're out in the field and you take some really bad photos, or you see a deer go by or something, you take you're capturing something else that shouldn't be on the report, you can actually say that in the field, which is nice, because sometimes you have to come back and delete it and rename it, and really the photo management part of this was a real plus. And then in the end, just to create these photo sheets off the server, once the data was validated and QA'd, you know, a matter of minutes, you could generate these photo reports in PDF format. Phil, how am I doing on time?
You're doing fine.
Okay, good. So then the GIS component was important as well. You know, we didn't have to do any really heavy-duty mapping. These were just site location maps. Multiply those by 600 though, you don't want someone to be creating 600 MXDs, which would also be a waste of time. So we came up with a way to automate that. Now, one of the challenges was figuring out exactly what we needed to show on these maps and what the regulations were requiring. Like I said, it was a little vague at first what they were wanting to see. Originally, they had asked for land use maps around all these different tanks, which we argued was probably not necessary and time consuming, and especially, obviously, West Virginia has a really good link data set that's pretty high resolution, but you know, creating that on this scale just didn't really make sense. Our guy, Jim Pinta, who Phil knows very well, he's quasi-retired now, playing a lot of golf, I think. He actually met with the regulatory agencies a few times, and we kind of nailed this down. But one of the things they wanted to see on these maps was abutting property and land use, which is shown at the bottom here. That was something that we directly pulled from the data, the tablet application, one of the screens. So those fields were pulled directly into SDE, which were used to make these maps. We created a Python script to automate the creation. Basically, it would, based on all the tanks we have in our SQL table, it would zoom in on every lat-long coordinate, map it out at the appropriate scale, add in the proper heading, the land use information, name of the tank, and then also receiving stream information, which is important for the SPR plans. Basically, it would create like a data-driven pages script that would create as many of these as we had in our system, which could be up to 600. And really just, again, in a matter of minutes, it would create all these maps in PDF format that we'd attach with our reports. I said several revisions in the format over the course of the project due to the vagueness of the policy. So imagine making 300 maps and then having to change something in the title block. Obviously, that's the strength of data-driven pages and some of the scripting that we did. Noah's going to...
You've got 7 minutes to go.
Got it. Noah's going to talk really quickly about the health and safety.
Yeah. And so as Mark mentioned earlier, as a requirement of CEC's policies, we are required to produce health and safety plans for each project we work on. So as you can imagine, producing health and safety plans for approximately 700 sites was not necessarily a challenge, but a necessary component of this project. We ended up using just basic near analyses to determine the nearest fire departments, hospitals, emergency, facilities. And I know some of you are thinking, well, that would have been better accomplished or more accurate with the network analysis, but in this tight schedule we had, we did not have time to produce a network data set. And I don't know if I would want to with these West Virginia roads down there, so that was not an option due to the time constraints. So we did a basic near analysis, and then with manual QA, we're able to basically quantify or qualify any outlying well locations that may not have been picked up in the near analysis. And the same thing was done for SPR plans with the nearest receiving stream. It was also a basic near analysis due to time constraints and not being able to do a surface analysis. So that's that.
All right, really quickly to close things out. Challenges, obviously, the tight schedule, reacting to some policy that caught everybody a little bit off guard. The records we got from Cabot were actually, I thought, very good, but there were still some holes and some gaps and some locational issues that we found in the field. One of the biggest challenges, noted by the picture at the bottom here, West Virginia is a great landscape, but it's got spotty cell coverage, or no cell coverage in some areas due to the terrain and kind of the rural nature of many of the areas that we were in. So that hampered our nightly data syncing. When you're syncing up photos, there's a lot of data that are being transferred. And I think looking back, there's probably a few other things, some tweaks we'd make to the syncing process to make it a little quicker. We were finding even some of the hotels that we're at, hooking into their Wi-Fi, they still weren't strong enough to support a lot of the data that we were sending. So, there was a McDonald's at some point that was
we ended up
doing that?
having to drive an hour to Beckley until we had it all figured out
Yeah.
every night to sync. So that was a challenge, but we had to overcome it that way. So.
Yeah. Really the summary was, this was a tablet application that, I think Cabot saw the benefits of it, but it was really selfishly helping us, right, complete our work quickly and efficiently, so that we can deploy all those troops and get the data back in a way that we could process it quickly. We saved a lot of time on the field side, but I think most of the time was saved on the reporting side, once we got the data to be able to create these automatic reports. FileMaker is great for automating these repetitive tasks, handling these workflows. I haven't worked too much with FileMaker, but it's a really nice technology to very quickly deploy forms and store them in a relational database. I didn't mention much about data quality. That was actually, I think, the title of our talk, but data quality was really assured through the, there's no hand transposition of data, electronic delivery of data from start to finish. So we were really capturing it as accurate as we were in the field. And then directly into GIS products as well.
And on-the-fly calculations.
Oh yeah, yep.
Real-time validation of all the form components. So.
Just really quick about future developments. We started this probably a year and a half ago, or even 2 years ago. Even since then, I think the technology has changed. ArcGIS Collector was around back then, but we were just starting to learn about that. Like we said, there was no real need for a high-resolution GPS component to this, but there could have been. And now with some of the Trimble products, the R1 and the Bad Elf receivers, you're getting sub-meter or meter resolution that you can hook up with an iPad or an iPhone. And looking back too, that would have helped us in some cases where we weren't quite sure where a tank was. And I mentioned too that developing a management dashboard for progress tracking real-time data analytics. This is a snippet from another application for BAT survey that we've done. It's an example of a FileMaker kind of management dashboard, tracking progress, tracking completion, actually looking at some numbers as they're coming in. And that's really the strength of more of a full-fledged data management application, which you can achieve using some of these tools.
So that.
Yeah, that's all we had.